Good afternoon, everyone. So, oh, where's the clicker? Here. Yeah, so as Klaus mentioned, LTE technology is basically looking at how to extend it and start using it, not only licensed spectrum as it has been used, but also unlicensed spectrum. And that's a trend that actually has started several years ago, and this kind of a diagram actually illustrates how the different mechanisms have been contemplated for aggregating or combining licensed spectrum with unlicensed spectrum. On the top part, we basically see two ways of doing that. One is purely an LTE-based solution, which is either the LTE-U flavor or LAA flavor. I'll get into a little bit more details on what that means. Where essentially you basically look at one licensed carrier from licensed spectrum, and you combine that with the unlicensed spectrum, forming what we call an aggregation. This morning, actually, Dave from Republic Wires mentioned channel bonding, what he calls channel bonding, for the voice solution that they have developed. And essentially, that's a form of aggregation between unlicensed spectrum and unlicensed, licensed spectrum and unlicensed spectrum. The other way of doing that, which actually is similar, is what is called LAA, which is essentially taking an LTE carrier from licensed spectrum from one of the MNOs and aggregating that with Wi-Fi. So there has been a lot of some developments on that front, different flavors of LAA as well, and that's being contemplated and by some of the MNOs. Now at the bottom, I have basically a description of purely unlicensed spectrum utilization. And of course, we have Wi-Fi and the Wi-Fi evolution, 11AC and AX and AD, and we, Qualcomm, actually fully leading some of that development in the IEEE and also with product and commercializations for AC and developing AX, but also in the millimeter wave. In the case of AD, we have a very good product there as well. But also, we started with some other companies developing what is called multifier, and that has been mentioned earlier in this morning as well. And essentially what that is taking this concept of aggregation, or LAA, and basically removing the requirement of having a licensed anchor carrier for the operation of the system. So basically turning the system, the LAA system, into a standalone, unlicensed, LTE-based solution. And there are some advantages and benefits you get by doing that. So these different flavors of LTE and unlicensed spectrum are being designed and developed by different organizations in collaboration with the industry. The LTE-U version has been developed in a forum called LTE-U Forum, and that's basically looking at the 3GPP LTE release 12 spec, and then building on top of that the coexistence mechanisms and requirements that would allow LTE-U to coexist in a fair manner with the incumbent in the unlicensed spectrum, which is the Wi-Fi. Then at the middle, we have 3GPP as the main standards body that develops LTE standards, and they are working on the release 13 version of LTE non-licensed, which is called the LAA. And then they're also working now, beginning on the release 14, I'll mention that, which is an extension of the LAA solution. And then on the right side, I have Multifier Alliance. That alliance was created at the end of last year by a few companies, and more companies are joining the alliance every week. And the purpose there is basically to take, again, the specifications that come out of 3GPP and modifying it to make sure that now you can actually operate in an environment where it's purely unlicensed spectrum with no dependence on the MNO licensed carrier. And the idea there is to have some product specifications, but also some technical specifications that would go above and beyond what's being done in 3GPP. Now, another way of looking at LTE and non-licensed and some of the benefits is once you aggregate a non-licensed carrier, let's say 5 gigahertz, with a licensed anchor carrier, then you basically are able to achieve much higher peak rates. So this is aggregation, is not selection of different interfaces. So you get the benefit of combining the throughput that you get from both systems, both the licensed and the unlicensed system. And that has been one of the primary motivations for MNOs to consider LTE and non-licensed, because it would be a very clear way for them to achieve speeds in the order of gigabits per second. So if you try to do that with pure licensed spectrum effort, in many cases the operators cannot combine and aggregate enough licensed spectrum to be able to reach the gigabits per second performance. But combining with unlicensed spectrum, then they can do that. We see benefits in terms of capacity and range relative to a pure Wi-Fi solution. And that has to do with some of the link performance and enhancements that have been introduced in the cellular system over the years, and they can can benefit in deployments like that. So the fact that you have a licensed anchor carrier adds the robustness to the system. So quality of experience and quality of service is significantly improved. And again, I go back to the example that Dave mentioned early this morning about how the voice service that was actually required in many cases to actually combine with the licensed spectrum to be able to increase the robustness and increase the performance of the voice service that Republic Wide is providing today. From an MNO point of view, this is a very interesting proposition, because they would essentially be able to have a single network. Basically, it's an LTE network that uses licensed spectrum and unlicensed spectrum. They can manage that network in a unified way. So that's also a benefit from an MNO point of view. But critical to that is the last point. It's clearly important to have a fair and Wi-Fi coexistence. Clearly, us and all the product proponents of LTE and non-licensed from the beginning, we had set the goal that make sure that a licensed spectrum has rules for attracting different technologies. It's not technology specific, but we all understand and support Wi-Fi, and understanding the fact that Wi-Fi is incumbent in non-licensed spectrum. So fair coexistence with incumbent is a requirement from the beginning. So how is that evolution playing out in the context of 3GPP? For those who are not familiar with the 3GPP releases and nomenclature. So the LTE-U version is the version of LTE that is based upon 3GPP release 12. And it's what's called supplemental downlink. So essentially, the unlicensed carrier is only used from the small cell to the device. So it's a downlink transmission only. There is no uplink transmission in the unlicensed spectrum. The uplink transmissions happen on the licensed spectrum of the MNO. The key components there for coexistence are based on dynamic channel selection and a concept called adaptive carrier sensing adaptive transmission, or CSAT. The combination of those two things basically ensure coexistence with Wi-Fi, and also LTE-U is set in a trajectory to support an upgrade path to LAA, which is the next step in the evolution. And LAA is really based on top of 3GPP release 13. And that is a standard that, I'll talk a little bit more about it, has been completed from a specification point of view, their interface specification point of view. And that the differences introduces a different mechanism that is required in many regions of the world, which is called listen before talk. There are some specific recommendations. For instance, the ETSI brand set of standards in Europe. They have a very specific set of recommendations for listen before talk, and that is being implemented in 3GPP release 13. The extension of that is release 14, which is a work that is happening now, which basically brings in the uplink portion of the LTE and LAA license. As I mentioned, both LTE-U and LAA are downlink only, but with release 14, the uplink portion is going to be introduced as well. I think I mentioned most of it here. The only part that I want to highlight is the fact that the release 13 standards are now they're being completed from my interface point of view. The part that is still being finalized is exactly the coexistence, the testing procedures to validate that the base stations, the small cells, actually comply with the regulations. And there has been a very good participation from the industry, including the Wi-Fi industry has participated in 3GPP, sending comments and providing comments to help the development of the specifications. So there are three aspects, I think for the audience here it would be good to understand. Three aspects that actually enable the fair coexistence between LTE-based systems in non-licensed and Wi-Fi. The first one is this notion of dynamic channel selection. And essentially, the system is constantly looking for channels that are not occupied by Wi-Fi. And we'll select one of those channels, if available, to transmit. And that is being done in a dynamic fashion. So it's not just done one time, and then you choose a frequency, and that's the only frequency you keep using it forever. So it's actually done in a dynamic fashion. That's a very interesting concept that even Wi-Fi doesn't have it, or most implementations of Wi-Fi don't have it today. The next one is this notion of listen before talk, following the, for example, the ETSI regulations. And that's a simple thing. You basically, you have some specific timelines where you have to, before you transmit, you have to measure the channel for a period of time. And then if there is transmission there, you basically back off, you don't transmit. And you only transmit when the channel is clear. So you do the first step, which is try to use a clear channel. If you can't find a clear channel, you do the second step, which is listen before talk. And the third thing, which is also being introduced, is whenever there is no traffic or very little traffic in that small cell, or that access point, actually the unlicensed channel is going to be released. And that's a very important concept that, again, it's available in the case of LTE-U and LAA because there is the licensed carrier anchor. That node can release the unlicensed spectrum and still operate on the licensed frequency only. So that's, again, a concept that the node doesn't need to keep transmitting probes, for instance, if there is no traffic to be transmitted or no activity on the devices. We have done a lot of testing last year, LAA showing performance and coexistence. This is a slide that basically talks to a trial that we did in Europe with Deutsche Telekom. Essentially went to their campus and did a lot of tests, indoor and outdoor tests with LAA. Licensed spectrum was 2.6 gigahertz, unlicensed in 5 gigahertz. But also we look at LWA, which is LTE plus Wi-Fi aggregation, and also look at the Wi-Fi standalone performance. And here are just some examples that highlights that's the campus environment that we had there. And it basically highlights coverage and the difference between coverage of the LAA solution and the LWA solution. And effectively, you get about a factor of 2 improvement in coverage. And that's highlighted there. We had other sets of results as well for indoors and so forth, but I just want to illustrate that one. And the other test that I want to illustrate that highlights some of the coexistence tests that we have done is we basically had a setup where we have 4 access points in a very dense environment. Some of them are above the energy detection threshold. Some of them are below the energy detection threshold. And basically, you create an environment where there is interference, lots of interference. And we start with the baseline, which is Wi-Fi only. All the access points are Wi-Fi. And then selectively, we replace these access points with LAA-based access points. And we measure the difference in terms of performance. And what the chart on the left shows is the Wi-Fi performance that you actually measure. And the first bar is when the scenario where we have all access points, all Wi-Fi access points. And then you get about 11 megabits per second of throughput. The moment on the step 2, we change one of those access points with LAA access point. And now we have the Wi-Fi performance actually improves to 16.3. And the reason for that improvement, it's about 40% improvement in throughput, is because now that access point used to be a Wi-Fi and now it's an LAA, it has a little bit better performance and it's able to serve its clients faster. And then once it serves its clients faster, it gets out of the medium faster, and that gives more time for the other Wi-Fi access points to actually serve its clients. So you get that indirect benefit and performance improves. And the third step is just switching one extra access point to LAA. So now we have 2 Wi-Fi and 2 LAA access points, and then you get a little further bump there, but not that significant. So overall, if you look at that, and on the right side, what I'm trying to capture there, if you take the sum total of throughput that all these 4 access points are able to provide in that area, we actually see that the mixing of Wi-Fi and LAA can actually improve spectral efficiency, can make the unlicensed spectrum more efficient, because the total throughput went from 43 megabits per second to 65 megabits per second for that same group of 4 access points and clients. So this is a very exciting result, and shows that it is not only improved performance, but also fair coexistence with Wi-Fi as well. So lastly, I mentioned multifier. Multifier basically is this concept that takes it further, whereby removing the requirement of having a licensed anchor carrier. And that opens up a variety of new business models and deployment models. And that essentially, if you think about certain, we talked about in the conference here, we have been talking about cable companies, their strategy, some enterprise and venues that actually can benefit by having a deployment of a standalone neutral host system, which is LTE based, and they can provide services to MNOs that are coming in, and essentially, essentially having the benefits of the continuity with LTE services in an environment where you don't need to have, a DAS system or 4 or 5 different small cells from each, from different carriers. So you don't need to have a Verizon system, AT&T system, T-Mobile, or Sprint system. You can actually have just one system, which is multi-fiber based, and provide that service to MNOs. So there's interesting business models that can come out of this technology, and we're very excited about that. So there is a multi-fiber alliance was formed, as I mentioned earlier, at the end of last year, and the founding members were Ericsson, Intel, Qualcomm, and Nokia. There are more members now, and more members joining every week. Dan Rabinovich was here from Ruckus. They're part of the forum, the alliance as well. And again, this is a very exciting opportunity. I think many of you in the room may consider joining and participating I welcome you to go and look at multifire.org and find out more about it. In summary, as I mentioned, there are many technologies that can coexist in unlicensed spectrum and combine unlicensed spectrum with licensed spectrum. It's all about the choice of the operator or whoever is deploying the system. The fair coexistence between these new technologies and Wi-Fi has been demonstrated and being enforced by the different alliances and different groups that are working on them. And multifire in particular, there is exciting technology which basically takes the performance benefits and some of the enhancements that came from the cellular industry. They actually combine it with the simplicity of the Wi-Fi deployment model, which doesn't require licensed spectrum. It has a much linear protocol stack. And so there's clearly many advantages for multifire technology. Thank you.
Eduardo, thank you so much for coming, and thanks for the presentation. Don't go away.
Yes, the panel.
We're going to have a panel in just a second. I'm going to introduce our moderator for this in just a moment. I just wanted to ask maybe one question while the panelists get ready, and that you did mention LWA.
Yes.
And I know you guys have obviously been super busy with LTE-U and with LAA. And the LWA story is has not come out as much. Is that you see it as a later phase of development, or is there, and how do you see that developing?
No, actually, LWA is being developed at way Qualcomm actually have developed it and demonstrated it. Okay. It's kind of available. It's a choice from in particular the MNOs. They have to decide what they want to do. We're seeing some traction in the market, but not as much as we would hope actually when we started developing.
Right.
But I think this is a matter of time and progression. There are different flavors of LWA as well. Okay. There's some flavors that are more at the IP network stack. And the version that is being developed, or has been developed into GPP, actually is further down the stack at the PDCP layer. That has some advantage for doing that in terms of performance. And that, we have, the solution are available.
Okay.
It's just a matter of market demand.
Are you trialing it with anybody else?
We have trialed it.
Okay. Eduardo, it's great. I want to invite you to join the panel here.